Okay, class, we'll take a quick, brief look here at using the law of sines, assuming that we've done the law of sines in the past, and so this is maybe a refresher, or maybe you've watched the other video from Dana Mosley. But anyways, when we have congruency back in geometry, we had congruency for angle, angle, side. Remember, two triangles are congruent if all the sides are congruent and all the angles are congruent. But if we could show three, angle, angle, side, that would be enough, or angle, side, angle. So when we're given that the measure of angle A is 38 degrees, when we write that in and we say, hey, that's 38 degrees, and we know that the measure of angle B is 54 degrees, okay, and the distance for A is 5, we've been given two things. We've been given angle, angle, and a side. Now, that means angle, angle, side. There's only one triangle in the world that has that. If we ask you to find the measure of C, when we set this up for law of sines, we're going to say C divided by the sine of angle C should equal anything else we know. In our case, we know this is 5 over the sine of 38 degrees. Now, the problem I have here is I don't know what the angle C is, but because the three angles in a triangle add up to 180, I can go and add those two up and get 2 carry the 1, that's 892. And so we take 180 minus the 92, and that comes up with our great 88. So that means over here, when we're going to find this, we know that this angle right here is 88 degrees. And then to solve that, we're going to cross multiply. So C times the sine of 38 degrees will equal 5 times the sine of 88 degrees. Now, the reason that we set it up this way, so I can get C by itself easier, I guess I wouldn't have to cross multiply. I could just multiply both sides by the sine of 88 degrees. If you put your unknown in the left corner, and then you can skip right to here, C equals 5 times the sine of 88 degrees divided by the sine of 38 degrees. Okay, now I'll let you go to your calculators to figure that out, but that's the usual use of law of sines. So today what we're going to look at is what happens if I'm given SSA. Well, I'm given the things. Now, first of all, in geometry, learn that backwards, that's a bad word. It's not a congruence theorem, and here's why. If we are given that piece of information, so if we're given that the measure of angle 32, A is 32, so I've given this, I'm given that distance A is 5, and I'm given that B is 7, okay, this right here, A, is a copy of the other A. So it's the same one. If I take that and I move it, if I can get a hold of this thing and move it over here, what you'll see is there's two possible triangles. There's the big outside triangle. Okay, we'll highlight this. The outside triangle in yellow, okay, that we're looking at. There's the yellow outside triangle right there that can have all of that. But there's also this nice magenta triangle right here that can have, and you'll notice that both of those have side B that's 7, both of those have the measure of angle A is 32, and both of those have an A value that's 5. So there's two different triangles that might be able to be created here. Not always, but sometimes they can create that. That's why side-side angle is not a congruence theorem. Now, if it's a right angle, yeah, hypotenuse leg. If it's an obtuse angle, yeah, it'll work. But in this case, we will solve this one. We're going to solve the whole triangle to figure out the information. So we take a look here and say, well, what would I set up here? Well, I would look at this and I'm saying, I don't know the measure of angle B. So I'm going to set this up and say the sine of angle B divided by side 7. That will equal the side A, which is 5, divided by the sine of 32 degrees. When I multiply both sides by this, I get the sine of angle B. Oh, wait a second. That's about the only way you can't do this. Okay. What do we get here? The sine of 32 degrees divided by side, which is 5. Oh, there we go. Almost. Catastrophic mistake. The sine of 32 degrees divided by 5 right there. So when we go to our calculator and we're going to figure this out, we're going to figure sine 7 times the sine of that 32 degrees. And then we're going to divide that by 5. So we get that 0.741. So when I go here, I know that the sine of angle B is about 0.741. Now what I'm not going to do is I'm not going to round this, but I'm going to figure out a possibility for the measure of angle B. So I'm going to go to my calculator and I'm going to say one of the possibilities for angle B is the sine inverse of the answer. Okay, so 47.89 degrees. So when I look at that, I'm also going to store that in alpha A, because I'll need that later. So 47.9 degrees. So one of my possibilities is this is 47.9 degrees. Okay? Now, the other possibility, because sine repeats itself, and remember that the sine of 180 degrees minus theta equals the sine of theta, okay? Remember that from our right triangle trig, if you will, that when we take our circle here, that we're going to have twice where we're going to be at that same height. Once will be in the first quadrant, and the second one will be over here. That means that if I take 180 minus that 47.9, I have another time when the sine of the angle is 0.741. So we'll go and we'll take on the calculator here, we'll ask it whatever 180 is, 180 minus that answer, and that is 132. I'm going to store that in alpha B. Okay, so that 132 is another possibility right there. So what this tells me is I have two possibilities for the measure of angle B. Angle B could either equal about 47.9, or angle B could be about 132. Now, at this point, I'm going to say, okay, if that's the case, can we figure out what the measure of angle C is? And the answer is, well, because the three angles add up to, here we have the 47, there we have the 132, but we have 32 in the other one. We can go ahead and add 32 to this. So we go 47.9 plus the 32, okay? And that's 79.9, that's about 80. And 180 minus the about 80, okay, is going to give us about 100.1. That would be the measure of angle C. Okay? Now, that's only if that was 47.9. So, if we go to this other plan, over here, we would say, oh, the 132 plus the 32 that was given is 164. Then we go 180 minus that 164. The other possibility is that the measure of angle C will be equal to, so what is that, it's about 16 degrees. So I'm going to have two possibilities here. I have the possibility when the measure of angle B is 132, and I have the possibility when the measure of angle B is 47.9. Likewise, then, when I'm trying to figure out the length of C, as we can look at the diagram and find out, there is a smaller length of C, there's the short length for C, and there's a longer length for C. So there's two possibilities. Well, there's this one here, so I can tell you that C divided by the sine of the approximately 100.1 should be equal to, and in this case we can say, what things do we know for sure? We know that this is 5 over the sine of 32 degrees. In the other case, we would say C divided by the sine of 16 degrees, 16 degrees, equals that same 5 over the sine of 32 degrees. So we'll have two sets of answers for this. And I don't want to bore you with that, but we can go here to figure that out. Next, give me a second. If we take a look here, let's see, 5 times the sine of 100 divided by 32. So let's see, how did we get that 100? So we went alpha A plus 32, and then we went 180 minus the answer, and that gives us the 100. All right, so we're going to take the sine of that answer. So we get that one, and that is the sine of the answer. We want to multiply that by 5 and divide by the sine of 32. Okay, times 5 divided by the sine of 32. And that one's 9.29. Okay, so 9.29 is the one possibility here. Right here, C equals 9.29. And the other possibility, okay, so we're going to have about the 16. So 5 times that, so we're going to go, let's see, alpha b, which was the how much? 132. We're going to add 32 to that, and then we're going to go 180 minus the answer. Okay, that's the 15, and we're going to take the sign of that answer. And then, when we look at that, that's the sign of the answer. We're going to multiply that by 5 and divide by the sign of 32. Okay, so times 5 divided by the sign of 32. And the other length turns out to be 2.58. 2.58. So we go back to here. My other possibility for the red over there is that C equals 2.58. Okay? And you can take a look at these to see that it'll make sense that when this is 16 degrees up here, that's going to be shorter. That's going to be 2.58, and that's going to be 5. However, when this is 100.1, so we take a look at here being, excuse me, yeah, when this up here is 100.1, the big angle up there is 100.1, then we're going to find out that this is 9.29 across the bottom, and that's going to be longer. Okay, so there's a case where we can do the law of sines to find what we call the ambiguous case. Again, all it was the fact that we were going to have two possibilities for that triangle. We have the smaller possibility for the triangle, and then we have the larger possibility for the triangle, the second possibility. Now, it won't always happen that you'll get two possibilities for the triangle. Maybe that's not going to let me move it over there. Okay. It won't always happen that you'll get those two possibilities, but you will see that when you try to figure out the second triangle. This gives you a little bit of an idea about the ambiguous case of the law of sines, and I'll be back on Tuesday to help you out in class.